Okay, so our problem is 233. Question is, let's read the question first. Determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. So it is asked us to calculate the resultant force. We have F1 here, which is given as the magnitude is 50 newtons, and F2, the magnitude is 35 newtons. And the angle between F1 and F2 is given to us. It is given as 120 degrees. Okay, so let's see how we can solve the problem now. Now, first thing is to draw the forces. Now, this is our x's are already given. Okay. So we have the x-axis and as horizontal and y-axis as vertical axis. Now we are given two forces. F1 and there exists another force, F2. Of course, this angle is given. The angle between these two are given. As 120 degrees. Now we will find the components. First, let's write the x component of the forces. F1x is equal to 50 multiplied by this angle. Sorry for the moment. So this is just corrected. This angle is 120 and this angle is given as 25 degrees. So since this angle is 90 degrees, this angle is 30 degrees. This makes F1x 50 multiplied by cosine 30. Okay, from here what we are going to find is 43.3 newtons. Now let's find the F1y. F1y is equal to 50 multiplied by sine 30 and it makes 25 newtons. Identically, we will find the x and y component of f2x. F2. Now f2x is equal to, this is f2x, by the way. Its magnitude, which is 35, but it has it's in negative x direction, so minus 35 multiplied by sine 25, and this gives minus 14.8 newtons, and f2y is equal to minus 35 multiplied by cosine 25, because also it is in negative y direction. So the value that we get is minus 31.72 newtons. Okay, now we can write the forces in Cartesian form. So F1 is equal to, by means of its components in x and y direction, 43.3 I vector plus 25 j vector, and F2 is equal to minus 31.72 sorry, this is so let me write it again. F2 is equal to minus 14.8 I vector minus 31.72 j vector. Now the resultant force is equal to F1 plus F2. As a result, I will just sum up the x components first. So 43.3 minus 14.8 I vector plus y components, so 25 minus 31.72 j vector. Now we can easily calculate the values. This gives us 28.5 I vector minus 6.0 72 J vector. So we have the x component of the resultant force and y component of the resultant force. Now what is asked? We are asked for the magnitude of the resultant force and direction measured counterclockwise from the positive x-axis. Certainly we can calculate the magnitude of the resultant force. Magnitude of the resultant force is Fr. That is the square root of squares of its components in x and y direction. So this is 28.5 square plus minus 6.72 square. This gives me the value of 29.28 newtons. Now I have to find the angle. So tangent theta is equal to FRY divided by FRX. Theta is the angle between the with respect to the x-axis. So this is FRY divided by FRX. So this value is minus 0.235. And from here, we can easily calculate the theta. Theta is equal to 346.77 degrees.